This is MEI Statistics Minor, Bivariate Data 2, Correlation Coefficients, 2.5, Calculating Spearman's Rank Correlation Coefficient. So a reminder, when we're doing a hypothesis test on Pearson's product moment correlation coefficient, we need to ensure these following assumptions hold. An alternative calculation we can use to establish whether there is association between two variables is Spearman's rank correlation coefficient. Note that word association. We are no longer looking at correlation. We are no longer looking at whether the relationship is linear. So this is a numerical representation of the relationship between the rank order of the two variables. In fact, it is Pearson's product moment correlation coefficient of the rankings. A test using Spearman's rank correlation coefficient investigates for a monotonic relationship between the variables. This simply is looking for a relationship such as if one value goes up, so does the other, or the contrary. We're not interested in whether that is a linear relationship. But the beauty of Spearman's rank correlation coefficient is that it requires no modelling assumptions. So the coefficient is represented by R subscript S, and this is applied to a sample only. Ranking a population is considered, well, infeasible if you think of how big a population is likely to be to then put everything in order. So this is only applied to a sample. Just like Pearson's product moment correlation coefficient, Spearman's rank correlation coefficient always takes the values between -1 and 1, and in a very similar way, -1 represents perfect negative association, 0 is no association, 1 is perfect positive association. Note again that that is not correlation. So for our example, we've got daily turnover at a cafe alongside maximum temperature outside. Calculate the value of Spearman's rank correlation coefficient. So the first thing we need to do is rank them, and I'd recommend you do this with extra columns. Label them daily turnover, rank, and max temp, rank. Now just put them in order by eye, so I can see that the smallest one is this one, which is 1. I'm going to cross it out so I don't get caught up. Next one there is 2. Third one is that one. One is 4, and so on until you've filled them all in, and do the same with maximum temperature. I always ensure that my rankings are in the same order, so my lowest one is always my lowest ranking, and my highest one is always my highest ranking. If you mix up either of them, then the association will switch direction, which you don't want it to do. If you're using IT, you can use the rank function in spreadsheet software. And note that you will not get any ties. In real life you will get ties, and you normally end up by averaging the values, so you might get some ranks of 4.5 for instance, but you will not get any ties. So you can then insert these values into your calculator and find Pearson's product moment correlation coefficient R of those ranks, and that will give you the value of RS, which in this case is equal to minus 0.6485 to 4 decimal places. An alternative method you can use is to use this formula, which is in the formula book. So this DI represents the differences between the ranks. So we want to use a new column, And I'm going to do 4 minus 6, which is minus 2. 9 minus 3 is 6. 8 minus 1 is 7. So I normally put in the negatives if it's a negative, but ultimately it doesn't matter because I'm going to be squaring it anyway. So you may also want a second column, which is a d squared column. But once I've got those d squareds, I add them up and find that my sum of d squareds is going to be equal to 272. Once you've got that difference, we just put it into the formula. So that's 1 minus 6 times the sum of the di squared, which is 272, all over n, which we know to be 10, times 10 squared minus 1. Run that through, pop it in your calculator, and you will get the same value, provided there are no ties. You may also be asked to calculate Spearman's using similar summary stats to the product moment correlation coefficient. In the next video, we're going to be doing hypothesis testing using Spearman's rank correlation coefficient.